I never bought a buoyancy. Mrs. Patter didn't say pick up a buoyancy on the way home.
You have a boat?
But Jacob, I really appreciate, like, you get what we're doing, and I really appreciate that. Like, I really do. I really do. I like it a lot. Yeah, you're awesome. You're awesome.
Force of water? Would that be a force?
Is water a dislodger?
Yeah. Force of gravity?
Force exerted by a flat, hard surface.
He's just mad that I beat him in G6 because I sit in the goal.
No more!
That's why he gets mad.
Motor.
Like it's made out of cardboard.
Yeah, I just said.
They love forces.
Me and Charlie
What?
like Charlie. I think I'm Charlie.
Not after 7 hours.
It's good.
Well, this guy is the boat, right? So these are the forces that are on the boat, not the forces that are behind the boat.
They don't fry though.
Well, force of the earth.
Okay, right? Ren, I know you're super into it.
I cannot see this. I cannot see this. No, I
All right, you ready? So, obviously, you guys were able to do it really easily. So the earth pulls it down, the water pushes it up. How do you know it's the water?
Because that's the surface that the boat is on. Surface. Correct.
So I think that the idea here is like, it has to be the water, because is there anything else interacting with the boat in any way?
No.
No. She said the fish. There's no fish in my fish mind. Okay. Yes?
So when something sinks in water, does that mean the water's still pushing up on it, but gravity is more forceful than like the water?
So this is a great question. So before we answer that as a question, we need to answer another question.
Oh, great.
Okay? What way is the water pushing?
Up.
Up. How does the water know to push upward?
It's resisting the change.
No, because that's just,
It's not
it doesn't know
moving,
anything,
yeah.
it just does it.
Yeah, but how, but
The same.
why does it push upward?
Newton's 17th law?
So buoyancy, we heard this before, but that's like a nickname for the force exerted by a fluid, in this case water. But does the nickname help us really understand it?
Well, kind of. No. Tension more buoyant.
Good word. Do you have your Canadian workbook?
So, how does the water, I mean, let me give you this example. Because we live in a place where there's water and sometimes pools, have you ever been in a lake or a pool and you grab your friend and you like pick them up and you can hold them underneath the water?
Yeah.
Have you ever done this?
Yeah.
Do they feel as heavy as normal, lighter than normal?
Very light.
Heavy. Much lighter. So here's the question. They feel lighter, right? The earth still pulls them down the same. They feel lighter. You don't have to hold up as much because the water is supplying some sort of up force on them. Because if you tried to lift them out of the water, as soon as they break the surface, what happens? They're super heavy again. So this is the same thing. The water is pushing up on the object or the person or whatever. So why is it that the water, why does the water push up?
Because
You see my question?
of physics.
It resists gravity.
No, not really.
H2O with the electrons, I don't know.
Is it hydrogen bonding? It is not.
AP,
It is not.
AP Bio? Maybe we should do AP Bio, just like get
The mass pushes up against.
what?
So what we're going to do, okay, is we're going to have to rely on your experience again. Okay, we're going to have to rely on your experiences again, and this may not have been your experience, and if you haven't experienced this, you'll just have to believe me. Okay?
Okay.
Have you ever dove deep into a pool? Like, I'm talking like 8, 10, 12 feet.
Yes.
Okay?
I've gone down
Your
there.
ears pop.
The shortest pool's like 12 feet, isn't it? Yeah.
So, how does it feel the deeper you
Oh,
go?
your ears start to get.
Is all the weight.
Your ears are like popping. More pressure.
Does it feel like there's more pressure on you the deeper you go?
Yes.
Okay, this, if you haven't had this experience, you may have it later in your life, but the deeper you go, the more you feel the water. Mrs. Pat and I were scuba diving once. I was like, oh, I'm going to go down there and check out those rocks. No, we were snorkeling. And so I like dove down, and the deeper I'm going, I'm like, well, this is more and more uncomfortable. Right?
Your ears.
And the deeper you go, you really feel the water pushing on you. Now, I will just a real quick aside. There's a slight difference between pressure and force. They're slightly different. Okay. We'll do a quick example. So take your pencil or your pen, whatever's in your hand, and flip it over to the blunt end, and I want you to press into your hand with a certain amount of force. Okay? Can you feel it?
With the what end?
The blunt end. Now turn it over, and I want you to press with the same force with the sharp end.
Oh, way more, yeah.
Does it feel different?
Yes.
Okay. So pressure
Who says no?
is the ratio of the force to the area. When you switched it to less area, you felt it more even though you have the same force.
Yes.
So in the way you're describing what you feel in the water, you say pressure, but force is okay for this context because force is something that we understand here. So tell me the rule. The deeper you go, the more force by the water.
Yes.
Is that okay?
Yeah.
The deeper you go, the more force by the water.
Why? Because there's more water. Oh, there's more area of water that's surrounding you? Yeah.
Yeah, I suppose you could. That's a fine context. So let's look at our box that's underneath the water here. Is there water above it?
Yeah.
Pushing which way?
Oh.
The water above it can only push down because it's above it. Okay. So I'm going to draw some force arrows here.
That's how things sink.
Is that cool?
Yeah.
This is only the force by the
Are we
water.
drawing that one too?
Okay. Now, is there water on the left side?
Yes.
There is. Which way is it pushing it? It's pushing it to the right. What do you notice about those arrows the way I drew them?
They get bigger.
They're getting bigger. Why?
Because as you get deeper, more pressure.
The deeper you go, the more force the water exerts. Okay? What about the right side? Which way is it pushing? Okay? And then what about the water that's underneath our little box here? Which way is it pushing? Up. And what do you notice about those three areas? Or arrows.
Same length,
They're the same length,
but they're bigger.
and they're all longer than the other arrows because they are the deepest. So tell me, if you were to add all of the water force arrows together, what way would the overall force point?
Oh.
Because the lefts balance the rights, the ups are bigger than the downs, so that means that the overall force by the water okay? So this is the answer to the question, how does the water know to push up? Obviously it doesn't know, it's not sentient, it doesn't want to or know how to do something, but this is, what's that?
You've never seen Moana?
No.
I don't
Sorry.
know.
You'll think differently about it.
Listen up. What's that?
Three children.
I have 4, and they have seen it. I haven't.
Well, why didn't you have a fourth one?
I do not watch Disney movies with my children.
So what do you watch?
Can that be the last thing can that be the thing we do like on the last day of school? Or before the final, we watch Moana?
No.
Oh my gosh, we definitely should watch Moana. If you haven't
Liz
seen
is like,
Moana,
yes, we're doing that.
oh yeah,
Alright.
we should go see the great state of Ohio where you grew up.
So this is, one of the things I want you to know today is that this is, when you look at the force by the water, water pushes things up. Like here, what's interesting is the boat isn't fully submerged, so it's actually a little easier to understand, like, well, of course it's pushing it up because it's underneath it, right? But even if you get your object fully submerged, the overall force by the water is always up. Yeah.
What if the box is like closer to the bottom of the
What if it's deeper?
yeah,
So-
so there's more
It's
room
still
on
the
the
same.
Yeah, this is a great question. If you move this box down,
The arrows.
the arrows on the bottom will get longer, but the arrows on the top will also get longer. And the difference between them stays the same.
Okay.
Okay?
So it's still pushing up.
That is a great question. The deeper you go, the overall force is more. Like each individual arrow would be longer, but the difference between them is the same.
Okay. Yeah.
So
Yes.
why?
So why do things
So right now, okay,
Well, that's my question.
What's
Why
your-
is there more pressure on the box as opposed to
Because it's forces.
so I think Charlie's, I'll get you this. I think Charlie's explanation is a good one. The deeper you are in a water column, the more actual fluid is above you.
Oh.
And so it pushes down and from all sides on you more. Because the weight of the fluid is more. Okay.
got it.
All right, so now what we're seeing here is the force from the water is up. So we have three different ways to analyze this. Okay?
Wait, I have a question.
Sure.
So would that box be moving up or would it be, is it stationary?
It depends on the weight of the box.
Because maybe gravity
Yeah, I'm
provides
just
more
saying like
force.
in the diagram, is it moving up?
Sure. No, the force from the water is up. But I don't know how much it weighs. Okay. So watch. Right now, we know the force from the water is up. Okay? The force from the water is up.
For the box?
Yeah, because you can see that the overall force from the water is up.
Sure.
Is that cool?
Yep.
So this is, I'm going to say FW, force water, FW, force water, FW, force water. Okay? Is that cool?
Yeah.
Now, we have three options as to what could be going on here. Is the Earth pulling it down?
Yes.
Sure, the Earth could be pulling it less than the water's pushing it up. The Earth could be pulling it more or
The same.
the same. So if I look at this box like right now, bam. If I'm noticing this, if the box doesn't weigh very much, and I look at it, what's it going to be doing? It's going to be accelerating upward because right? If you ever try to take like a basketball or something, you like push it underneath the water and let it go, what happens to it?
Shoots up.
It accelerates upward because it's not very heavy, but the force of the water is big. What if you take a rock? What if this is made out of like granite or steel or something? If you put it in the water and you let it go, what's it going to do? It's going to accelerate downward because the force from the earth is much bigger than the force from the water. And this is the greatest one. What if they're equal?
It just floats.
So what it does is it just stays where it is, called neutral buoyancy. It just stays where it is. What's that T with the little things in it? It's got T. It's got like little like bubbles or something in it. What's it called? Boba tea?
Yeah.
These things don't sink to the bottom, nor do they rise to the top.
They sink to the
They
bottom.
sink.
They're at the bottom.
Don't they just stay in the middle?
No, they sink.
It depends.
Well,
Some of them float, some of them
I-
sink.
depending
They're a
on how
little
you get
sketchy
it.
sometimes.
That's kind of gross. Anyway,
Yeah, they're definitely like GMO or something.
No, it's just like.
Like they're definitely like cross.
well, think about it this way. If the individual little bubble thing
like
was heavier, it would sink. If it was lighter, it would rise to the surface. And if it was the same, it could just stay where it was. You can actually do this in the water if you've ever been swimming. If you take a huge breath, you will rise to the top. If you blow out all that air,
You'll sink.
you will sink to the bottom. And you can get it just right so you can stay neutrally buoyant.
Is that why free diving? So where is
Neutrally buoyant.
It's so what you do is when you breathe in really big, you actually expand your chest cavity and you have more volume. Excuse me.
You can go underwater for a minute. Whoa, that's like superhuman.
That's a lot. That's cool. All right.
I can stay under for like 10 seconds and then I'm done. Like for